Today we're going to be talking about linear programming. So in the example we're given, food and clothing are being sent by commercial airplanes to hurricane victims in Florida. Each container of food is estimated to feed 12 people. Each container of clothing is intended to help 5 people. Organizers of the relief effort want to determine the number of containers of food and clothing that should be sent in each plane shipment that will maximize the number of victims helped. So the first thing we need to do is determine our variables. What's going to be X and what's going to be Y. And since we're trying to determine the number of food containers and the number of clothing containers, I'm going to make X food and Y clothing. Next, we need to write our objective function. This is an equation that determines the maximum or minimum. So for our situation, we want to write an equation that expresses the number n of victims that can be helped in terms of X and Y. So n. We know that the food container is going to help 12 people, so 12x, plus clothing is going to help 5 people, so 5y. And that's our objective function for this example. Constraints. These are our restrictions. So, the weight and space restrictions imposed by the airlines are summarized as follows. The total weight cannot exceed 19,000 pounds, and the total volume must be no more than 8,000 cubic feet. Each container of food weighs 50 pounds and occupies 20 cubic feet of space. Each container of clothing weighs 20 pounds and has a volume of 10 cubic feet. So we're talking about two things here, weight and volume. The weight cannot exceed 19,000 pounds. Food weighs 50 pounds. Clothing weighs 20 pounds. So if we were to write that as a linear inequality, we know that 50x plus 20y has to be less than or equal to 19,000. Because we can't go over that or the plane won't be able to fly. The volume can be no more than 8,000 cubic feet. The food is 20 cubic feet and the clothing is 10 cubic feet. So 20x plus 10y has to be less than or equal to 8,000. Now when it comes to our containers, we have these restrictions, but technically as high as x and y want to go, we can have any number of them. The thing we can't have is we can't have negative numbers of boxes. So x has to be greater than or equal to 0, and y has to be greater than or equal to 0, because we can't have negative containers. Feasible region. This is a graph of possible outcomes. So anything in the shaded area of our graph are possible to happen, but ultimately we're going to look for the maximum ones that can happen. So if we use the cover-up method to graph these, we need to solve 50x equals 19,000. And 20y equals 19,000. And then for our other line, 20x equals 8,000. And 10y equals 8,000. So if we solve all these by just dividing, here x would equal 380, and here y would equal 950. Here x would equal 400 and y would equal 800. Because we don't want any negatives, I'm going to treat this corner like my x and y axis, like this corner is 0, 0. And I'm going to graph the intercepts so that we can get all the way up to 400 for the x's. I'm going to count by 20s, so every 5 boxes is worth 100. And for the y's, I need to get up to 950. I'm going to round up to 1,000 because there's 20 boxes. And I'm going to count by 50s, which means every 2 boxes is 100. And then my x-axis is representing the food containers, and my y-axis is representing the clothing containers. So our first line has an x-intercept of 380, so 300, 320, 340, 360, 380, and a y-intercept of 950. I'm going to use my ruler to connect those. So we want to know exactly where these lines intersect. That's really important. And then my other line has an x-intercept of 400 and a y-intercept of 800. Again, connecting with my ruler. And because both of our inequalities had less than, I'm going to shade everywhere that is below both of these lines. So I'm going to start off down here below the blue one, and then when they cross, I'll stay below the red one. So everything in that pink area is my feasible region. So those are the amounts of containers we could send to Florida. If a maximum value for the number of n hurricane victims to be helped exists, then that maximum must occur at one of the corner points. Determine the corner points of the feasible region in Part A and list them in the chart below. So we're looking for the 4 corners on the sides of the pink. So the first one would be 0, 0. 800. 300, 200. And 380, 0. So now we need to determine the value of our objective function, which we wrote at the beginning. That's our n equals 12x plus 5y. So for each coordinate we have an x and a y, and we're going to plug it in. So 12 times 0 plus 5 times 0. 12 times 0 plus 5 times 800. 12 times 300 plus 5 times 200. And 12 times 380 plus 5 times 0. So now we're going to type each of those into our calculators. So someone would get 0, 4,000, 46,000, and for the last one we get 4,560. So what is the maximum number of hurricane victims that can be helped? We can help 4,600 people by sending 300 containers of food and 200 containers of clothing. And that's it. See you in class.